All right, welcome to Module 6, Lesson 8, Drawing Triangles. Okay, hopefully you girls and boys will end this lesson understanding the question that is going to drive, lessons 8 through 11. And those are what conditions, for example, how many measurements and what arrangement of measurements are needed to produce identical triangles. Okay, so what do we actually need to be very certain that we will be creating identical triangles? Okay, also hopefully you'll understand better what conditions are needed to produce a unique triangle. Okay, a triangle that is very unique. Okay, more or less a custom triangle. Okay, so understanding how the triangle is put together under given conditions, will help you guys answer that question. Okay, you're going to be drawing some triangles based on some conditions. One triangle, a handful of triangles. Okay, all right, and we're going to ask you every now and then whether the conditions yielded identical triangles. Okay, so in that vein, let's go ahead and look at this first, this opening activity here, the classwork. So what I'd like you to do right now is on your paper here, go ahead and use your protractor and a ruler to draw the right triangle DEF. Okay, the only thing that's being told here is that you are going to draw a right triangle DEF. Label all sides and angle measurements. Okay, yeah, I don't want to get into the rest of it, but just go ahead and do it. Okay, so the idea, of course, is to do this in class, and the part I didn't read to you was this here. Predict how many right triangles drawn in the class are identical to the triangle you have drawn. Well, based on the fact that I only asked you to draw a right triangle DEF, that's what I drew. Okay, what didn't I do? I didn't actually do the, didn't do my D. Let's just do it this way. Actually, I'm going to do D here, E, F. Okay, so I drew that's my right triangle. Okay, and it is, let's see, I can measure it here, a few centimeters in height. I didn't really do it any particular way. It was like 2.5 centimeters high. Okay, but it is 90 degrees, as we can see right here. Okay. I did check that out. So, the idea is this. How many right triangles, again, the next thing you would do, how many right triangles drawn in the class, you go around looking, were exactly identical to yours, okay? It would be really, really hard, real long shot to think that in our class, unless somebody was working together, in a class of even 14 or even 30, that people would have created identical triangles, because those triangles, some of them are going to be steeper than others, some are going to be pretty wide. Okay, the only condition was that they were 90 degrees. Okay, 90 degrees. All right, so the idea is, in the end, it is difficult to draw identical triangles unless you have some conditions set forth. Okay, the next thing I wanted to talk about, that I have some in my teacher notes, are these different notations here. Okay, prime notations are used to distinguish two or more figures that are related in some way. Okay, so take for example two different right triangles that have equal side lengths, okay, and equal angle measurements under some correspondence. Okay. If the first triangle, DEF, is as shown, what letters should be used for the vertices of the second triangle? Well, they go on to say that these are identical, of course. You can't use DEF again because, of course, that would be two DEFs. It would be very confusing. All right. Instead, we could use, D with the little accent mark or hyphen, or not hyphen, but a little dash right there, not a dash, but little prime notation there, and D with the notation, E notation, F notation, that's only one little tick there, okay, which actually reads D prime, E prime, and F prime. So in this way, the letters show the connections between the two triangles. Okay, it shows that these are all identical. Okay, but we use this prime notation. They're two separate triangles. Now, if you had a third, it says right here, you could use a double, call them double prime, D double prime, E double prime, F double prime. Okay, so all of these are equal or identical triangles. Okay, using prime notation. Okay, well, this is an interesting problem here. I'm not going to make this any super secret, drive you crazy on how to do this kind of thing problem. So we're just going to go ahead and do this together. So it says here, so given the following three sides of triangle ABC, okay, use your compass to copy the triangle, all right? And I'd rather, actually we're going to use the compasses, right? Okay, so the longest side has been copied for you already. Okay, that is the longest side there. Label the new triangle A prime, B prime, C prime. Okay, and indicate all side and angle measurements. Okay, it says as a reminder of how to begin, refer to lesson 6, exploratory challenge, question 10. But I'm just going to tell you again what you're going to do. You are going to be using the compass. Okay, so these are the sides. So this one's already been used, already been drawn for you here. Okay, so you can get another piece of paper, and actually, as I do it for you, okay, you can do it with me. Now, again, it's really difficult because these measurements are not exact. I measured AB, for example, and I think in my packet here, and I come up with like, 27 millimeters. All right, so it's nothing clean in terms of like centimeter wise. Well, I guess that BC segment here is 4 centimeters, which is nice, and then AC. It's also kind of kooky, maybe about 53 millimeters, 5.3 centimeters, okay? So anyway, let me go ahead and do this step by step for you, showing you how you can use circles to make triangles, okay? So let's go ahead and do it. Okay, so what we start with our segment AC, okay, and I measured that out as 4 centimeters, okay, and then I'm going to look at the fact that I have one of those sides, another one of those sides to my triangle is going to be about 2.7 centimeters. Okay, so let's just go back to this one here. So here's AC. Now my B is going to end up over here somewhere. Okay, it's going to end up over there somewhere. Okay, so so I got to get rid of that. Okay, but I know that it needs to be 2.7 centimeters away from A. It's going to be moving that way. Okay, well, not in this case, but actually, if I went back, just went back here. Yeah, so B is going to be, it's going to be somewhere like that. That's going to be 2.7 centimeters. Okay, that's what I want. I don't know what it looks like right now. Okay, because I still need to work with my protractor in my compass to figure that out. So again, I have this here, and I know it needs to be 2.7 centimeters. So what I need to do now is take my compass, okay? So my finger right here is right on point A, okay? And you can see point C behind there, okay? And what I've done is I've dialed in to right here, look at this, 2.7 centimeters right here, also known as 27 millimeters. Okay, so I've dialed in there. I have my point there. So there's my where my pencil is going to go, of course, right in my notch there, and I hold my, the point on the vertex, and that point right there is A underneath my finger there. Okay, so when I do turn it, okay, let me just get rid of all this, okay. When I do make my circle now, because I'm going to make a circle here, I'm going to come up with that. Now, my circle, since I set a radius of 2.7, okay, 2.7 centimeters, what I know about this circle is that, and I talked about this before, every single chord that comes off of that center and goes to the edge are all going to be the same length. And this is the beauty of a circle and how a circle can help us make perfect triangles, okay, or help us communicate the dimensions of a triangle, okay. So that is really, really nifty, okay. And let me just get rid of all those, and we'll just move forward. Okay, so after that now, I know that my BC, okay, my BC, which is going to move off that B to the C, is about 4 centimeters long, okay. And I'm going to do the same here, okay. So I am putting the crosshairs right over the end of that segment there, which is point C, okay, and dialed in now to 4 centimeters, all right, and I'm going to go ahead and spin, put my pencil in and spin and get that, okay. And again, just like with the circle that had A in it over here, okay, this right here, this radius is 4 centimeters, therefore any chord coming off of that, those are all 4 centimeters. Those are all lines of radius, okay? Okay, off from that, from the center. So get rid of those again, okay? All right, so now what do we do from here? Well, what you can do from here is you could choose actually 2 places to put point B. You can either put point B here, or you could put point B here. It doesn't matter, okay, because you've made circles. So I've chosen to actually put point B right here, okay. So this is my point B. I'll denote it later, okay. But all I need to do here now is to draw a line from my point A here to this point where the 2 circles intersect, because I know at that point where those 2 circles intersect on that side within the circle that's made with A as the center, I know each one of those is going to be 2.7 centimeters, okay, and that's what I needed, okay, that's what I needed to have, okay, I needed that. That was one of my my conditions, okay. And then, of course, what do I do for C? For the other side, I just draw a line from what is now B over to C, and that is 4 centimeters long as well, okay. So you can see how beautiful and how wonderful this all is. Well, I sure hope it is for you guys. And you can see here, see now, this is going to be the same length as that, okay. And in fact, that bottom, I said that bottom line was actually 4 centimeters, but it's truly not. Let me go ahead and just measure with that whole. That whole line is actually 5.3. This wasn't. I mismarked this here. This is 5.3 centimeters there. Okay, that is that bottom, the bottom side right there entirely. But these 2 lines here are both 4 centimeters because those are both lines of radius within this larger within the larger circle. Okay, and there you go. We have drawn our. Actually, I want to keep that there. We have drawn our triangle, and again, your triangle you could have used this as B, whereas your triangle would have looked just upside down from mine. Okay, so here is our exploratory challenge here for this lesson 8. you are going to be drawing a triangle given two angle measurements and the length of a side. Okay, so that's going to happen. You're gonna get that. Okay. Then you will rearrange the measurements in as many ways possible and determine whether the triangles they drew are all that you draw are all identical. Okay. So we're going to conclude the lesson with this question. Say which pieces and what arrangement of those pieces guarantees that triangles drawn are identical. Okay, so again, you're going to see, we're going to starting from C here, right here, C, you are going to be given different, you'll see there's C and then D and E. These are three triangles, okay, so based on what they give you, the measurements they give you, you're going to draw them and you're going to decide whether they are identical. Okay, identical. So you're going to be using a protractor, a ruler, a compass, whatever you need to create these triangles. All right. I would say go ahead and use grid paper for all of these, so as to make this a bit easier for you to make straight lines. And if you want to just go ahead and say, I don't know, use each grid box is equal to a centimeter. Just call them units if you want to, but if you can, go ahead and use your ruler and actually do some true measurements. Okay, so go ahead and do this. Let me just go ahead. I'll read this to you, and then I'd like you to go ahead and actually finish this entire exploratory challenge and get all the way to having completed E, and then we will talk about F, and then maybe G, H. I'm not sure how many of those we'll actually do, but yeah, so here we go. So a triangle is to be drawn provided the following conditions. Okay, here are the conditions of this triangle. The measurement of two angles is 30 degrees and 60 degrees, and the length of a side is 10 centimeters. Okay? Note that where each of these measurements is positioned is not fixed. Is not fixed. Now that should be a hint right away about their identicality. Okay? And so it says here, how is the premise of this problem different from exercise 2? Okay, so exercise 2 that we just did, we're only making one triangle, and it was stated very clearly as to the different measurements of the sides. Okay, the side measurements. We actually weren't given. I'm sure we actually weren't given any angle measurements in that exercise 2. So anyway, yeah, so it is quite different. It says here, B, given these measurements, do you think it will be possible to draw more than one triangle so that the triangles drawn will be different from each other? Or do you think that attempting to draw more than one triangle with these measurements will just be producing the same triangle, just turned around or flipped about? Okay, well, that's something to think about. I'm not sure what your prediction is here, but that's something to think about. And once you do think about it, just go ahead and get started. So you can see the conditions they've given you for C. They give you some conditions for D and then conditions for E. And at the end, we'll ask this question: are the three triangles drawn identical? And then justify your response using measurements. Okay, so go ahead and do that, and then come on back and we'll look at it together. Okay, so we'll start off with this, with the triangle we're going to draw for letter C here. So based on the provided measurements, draw angle ABC. Okay, so that angle A equals 30 degrees, angle B equals 60 degrees, and then segment AB equal 10 centimeters. Okay, and then you're going to go ahead and describe how the 10 centimeter side is positioned. So I'm going to go ahead and show that to you right now. Here's what I came up with. Okay, so yeah, and here is my that first triangle, and you can see, so in terms of, and you can see here I got my 30 degrees here, 60 degrees here, and you can imagine this is, of course, if we flipped it over, is a right triangle, because this is going to be 90 degrees there, okay? But they didn't ask us that. But what they did ask us, though, at the end here is describe how the 10 centimeter side is positioned. And that 10 centimeter side, its positioning in this is it is actually between angle A and angle B. Okay, between angle A and angle B. Okay, so that's where it lies. Remember, we had these definitions, or this terminology we used before. Okay, all right. So let's move on. We're going to do the next one. See what we come up with for D. Okay, so for the next one, here's what I came up with. And again, our the measurements we were looking at. Remember, we had. And again, this is prime now. This is all going to be labeled, as you can see, I've labeled it A prime, B prime, C prime, okay, with a little, with the notation, right over here, this notation right there, okay, on all three of those, the vertices. All right, so anyway, yeah, remember we had A as 30 degrees, which was the same as before, B as 60, which is still the same as before. These are angles, okay. But now we had changed something. We had, instead of having the line or the segment between angle A and angle B as being 10 centimeters, we had this line here between angle A and angle C. Okay, we could also say in terms of where it's positioned, we could say that the 10 centimeter side is opposite of angle B. Okay, all right, it's also opposite of angle B. Okay, and one more to go. Okay, and that's here. Lastly again, use the same measurements to draw. Now we have A double prime, B double prime, C double prime, so that angle A double prime is equal to 30, angle B double prime is equal to 60. Those are the same. And B double prime, C double prime, which is the segment, is equal to 10 centimeters. Okay, and you can see now we've shifted that as well. So I think you're going to get the idea. I'm not going to go and I don't feel like drawing it right now, but again, hopefully when you drew that last one, that was a little tricky. I got to tell you. Actually, let me go ahead and draw this one and just talk about the process that I went through, because it's a little bit different when you don't know the the length of a well, I guess it doesn't have to be tricky actually. Well, anyway, let me go ahead and draw it. Okay, so here's what I came up with for this last one, for letter E, okay, where we had, again, the tricky thing is, I mean, if you hear about all these triangles, you're always hearing that, the A angle is 30 degrees, the B angle is always 60 degrees. So those stay consistent from, AAA, and then A prime, B prime, C prime, or A double prime, B double prime, C double prime. Okay, all three of those triangles, they have that in common. They also have, what they have in common is they have a leg or one side that is 10 centimeters. But that side always changes, okay? It's always changing. So because it's always changing, it is changing the triangle itself. Even though, I mean, if you look at them side by side, they don't seem so very different, but you would notice, well, I guess they do look quite different, because when you have this very large 10 centimeters, this long 10 centimeters, this one, if I look at mine, that last triangle was much bigger. Okay, and in truth, they grew bigger and bigger and bigger. I didn't say, boy, I guess they look similar, I mean, in their proportions and such, but they are different, and you can see that as they tended to grow. Okay, from our first the line here was 10 centimeters initially. AB segment was 10 centimeters, and then we had this AC segment was 10 centimeters, and now we had the largest triangle was this the BC side. Okay. So yeah, anyway, again, as far as the trickiness of doing this one, the way I did this one here was I drew my first line here. Okay, I drew my first line here. I went ahead and dialed in using my protractor. Okay, I dialed in to my 60, put my notch here, my notch right there at the point of the vertex. Okay, found my 60 up here, put a dot down, drew my line. Okay, and I knew this line had to be 10 centimeters, so I was good to go. Okay, 10 centimeters. I could draw that line, no problem. Now, I knew this was a right triangle. It's a right triangle because this is 60, this is 30, 90's left over. So I know they're all right triangles looked at in certain ways. So what I did is I took my protractor again, okay, and had it so I had my 90 degree right up here. Again, my notch right there at the vertex, and then my 90 degrees here. So I knew which direction I was going. So I just drew this line, drew it, okay, until I crossed this line. And if I didn't cross, actually I did cross it, but if I didn't cross it, I could just have extended this line, okay? Because I don't know, this line right here is the big unknown, okay, as to how long it is at the beginning. The only one I know is this one, okay? Oops, no question mark there. I do know this one, all right? I don't know either one of these. I don't know that one either, okay? But once I get my location of C up here, okay, because I knew this, then I can just dial into my 90 degrees on my, again, on my protractor, okay? And then draw that, put my dot, and then draw that line. So it reaches out, until it comes to a point where this crosses. And then that I know is then that becomes my point A, in this case A double prime. And then I just went and checked, make sure, and I did, and I saw that it was indeed a 30-degree angle, which is very, very satisfying. Whew. Anyway, if you need any, I don't know, any tutoring with any of this, just let me know. You can come on in. We can sit around and use these tools. Actually, a lot of fun, especially those of you who like to draw, maybe more mechanical drawing. This might be right up your alley. Okay, so we've already talked about F, which asked, are the three triangles, drawn triangles, identical? And we know they're not. Okay, they're not because, while the angles measurement stood the same, it was always 30 for A, 60 for B, and then 90 for C. The sides changed. They just all shared that 10 centimeter length, each subsequent triangle. Okay, so now G here asks you draw triangle A triple prime, B triple prime, C triple prime. Okay, so that B triple prime equals 30. Okay, C triple prime equals 60, and this the segment B triple prime, C triple prime equals 10 centimeters. Okay, is it identical to any of the three triangles already drawn? Well, the truth is it has to be, okay? Because they have stayed the same, things have stayed the same here. We still have a 30-degree angle, but they're calling it angle B triple prime now, okay? And C triple prime is 6. Now this is, so if we draw this thing, I'm not going to go through this, and I don't need you to go through this either, but I just wanted you to see, and then we have one of the sides is equal to 10 centimeters. Now we've already exhausted that. I mean, our basic triangle looks like this. We've already moved that 10 centimeters around to each side. Okay, it's been here, it's been here, it's been here. Now in this case, I mean, it's going to have to be one of those. All right. So if we said, oh, here we go. So let's just say I'm just going to use this cheesy little one here. This is going to become angle B here. Okay, which is 30 degrees. All right, we can see that's the more acute. They're both acute triangles, but that's the more acute one. And then this is going to be, again, this is triple prime. It's a different triangle. boom, boom, boom. Okay, this is 60 degrees, all right? So now we have the segment B triple prime, C triple prime, right here is 10 centimeters. And if you remember, that was one of the first ones that we did. Is it the first one or the second one that had that? Not exactly sure. I have my papers all strewn about here. That was, wasn't that in part C? I don't think that's part D, but I think that was part C, right? If I have this right, because I think, where do we have? We have B, angle B here. B triple prime is 30. C triple prime is 60. That's it. This A triple prime here is going to be 90. Okay, yeah, this looks identical to the one that we did in part C. It's interesting because I have, it looks like in my notes, my teacher's guide here, I see that it's saying that it was similar to part D, but I think it's C. So anyway, if you see that I did something wrong, let me know. Okay, this next one, H, draw another triangle that meets the correct. Nah, don't bother. Haven't you had enough? I have. But if you want to, go ahead. Okay, lesson summary. Here we go. The following conditions produce identical triangles. Okay, 3 angle measurements and 3 side lengths. Okay, you need those. Okay, there is only one triangle with the side lengths 10 centimeters, 10 centimeters, and 17.4 centimeters with angles 30, 30, and 60 degrees as arranged above. Okay, you need this criteria. You need 3 angle measurements and you need 3 side lengths to create identical triangles. Okay, it's the only way. I don't know, this does not seem very profound and important to me, but I guess it is. I mean, you just can't go by one simple measurement, one side, to draw or to think that triangles are identical. Okay. Yeah. So I think that's it. I think we're good. And let's go ahead. If you have any questions, again, if this was confusing and if I rushed at the end, if it seemed like I rushed at the end, it probably is because I did. But we are going to move on now. It looks like 9, 10, and 11 are going to draw upon what you've learned here. So you can look forward to that, okay? Hit your problem sets, and see you in Lesson 9.